Hello everyone, my name is Arpit Singh from IIPS DAVV, and in today's video we're going to see how to solve numerical analysis and design question paper from first internal. In first question we have to write an algorithm to accomplish the task for polynomial px given in the following table. Here a polynomial px is given in which we have to perform following tasks like evaluating the polynomial, dividing a polynomial by x minus r, and finding differentiation of the polynomial d of px by dx by both brute force techniques and recurrence relations. The solution of this question is first for evaluating the polynomial we have to calculate every term like a n xn plus a n minus 1 x minus 1 plus all the terms that there are, and then we have to add all these terms in brute force technique. The algorithm for this is start for ai is equals to n minus 1 to n in steps of 1 sum every multiply every term with ai xi and then store its value in the sum variable. Then we have to return sum, and that's how algorithm works. This algorithm multiplies the what is the degree of n, like suppose here x has degree of 5, so x gets multiplied 5 times, so this algorithm takes big O of n square time complexity. A much optimized method is recursive approach, in which using Honer's method we can rewrite the polynomial as here we have taken a common element from every term in the polynomials. Here a0 x a1 x, we have taken common element from every term, and then we add these terms, so the multiplications done in the approach reduced by a lot. Here a function is df evaluate I and x. It takes I if equals to 0, it returns the value, or else it solves the function recursively for every term I minus 1. It solves the evaluate, then stores, then returns it to its call. The time complexity of this algorithm is big O of n. The task 2 is to divide the polynomial px by x minus r. In brute force algorithm, we read all the coefficients like n, the degree of polynomial, all the terms a 0 to n, and the value r in which we have to divide from. We initialize temp array from 0 to n and quotient array from 0 to n minus 1. In this algorithm, for I is equals to n to 1 in steps of 1 minus 1, the quotient is replaced by the temp, and for j is equals to 0 to I, the temp is acts as reminder, and subtracting quotient from it return the result at temp of j. The reminder then gets stored by temp, and quotient and reminder are then printed, and end of algorithm. This algorithm has two loops that works from n to 1 and from 0 to I. So the time complexity of this algorithm is also big O of n square. The recursive method of dividing polynomial is we can use synthetic divide technique. In this, we recursively call synthetic divide for the lesser term and then returns it to its call. The time complexity of this algorithm is big O of n, since every term just gets called once. To find derivative of a function like d of px by dx, the brute force technique is to reducing the power of every term by 1 by using a for loop for I from 1 to n. We are appending every term in the d. The d is derivative list. We have initialized it, or I into a minus 1. A minus 1 are coefficients, and I are the term from I loop, for loop. So this way the brute force technique works. It has time complexity of big O of n square, since every term gets called 2 times. The recursive algorithm of solving this is start read n from a I to 1 and finding derivative by every term, finding derivative of every term once, and then passing it to its call. It stores result in the derivative list. The time complexity of this algorithm is big O of n. In second question, we have to write the algorithm flowchart for the following tasks and complete the table. We have tasks like subtraction, multiplication, and division, and we have to write algorithm for all this. In solving this question, we write a general algorithm in which we start and take n1 and n2 as inputs, check the operation if it is of subtraction, multiplication, or division, and perform respective operation and display the result in scientific notation at the end. We can also check if the n2 is equal to 0 or not so that division operation doesn't cause any error. In task 1, n1 is 0.5452 e minus 99 and n2 is 0.524 e minus 99. By solving this scientific notation, we can take 10 to the power minus 99 common from these two terms, and then after solving, we can append it by 2.8 e minus 102. In task 2, we have to multiply these terms. For multiplying, we take the exponential part common, 10 to the power 151 and 10 to the power 15. And then after multiplying these respective terms, we append it at end at last. So final result is 1.37074 E164. The third task is to divide these terms. For division, we have n2 as 1.0.1000 e minus 99. So it can be written as 10 to the power minus 99 and the n1 can be written as 9.998. While dividing, the 10 to the power minus 99 can get reciprocaled and 10 to the power 99 it can become. So 9.998 e 99 is the final result. In question 3, we have to verify associative law and distributive law of arithmetic with fitting 4 Mantis digits and provide correct answer if no number is truncated. In provide for associative law, we have to check a plus b plus c, in which a plus b is done first, is equals to a plus b plus c, in which b plus c is done first. By evaluating these a, b, and c, we get these values of a, b, c. If we do a plus b first, a plus b results to 5.72056, and if we had c at last, 11.36456. If we do b plus c first, so b plus c results in 5.69956. Now a plus b plus c results in 11.36456. These values are equal, so associative law are verified. In finding distributive law, we check a into b minus c is equals to ab minus ac or not. In here, we calculate b minus c first, which results to minus 4.50755, and a into b minus c. If we multiply a into this term, we get minus 25.0.4257. In step 2, we compute AB minus AC. So AB results in 0.25243 and AC results in 25.294. So if we subtract AC from AB, we get minus 25.04257. These two values are also equal, so distributive values. Distributive law is verified in these terms, the given terms.